friends, welcome to my channel. Today we are going to study geotechnical engineering. Today we'll start with the questions. First question: residual soils are formed by. Here option A glaciers, option B wind, option C water, and option D none of the above. Here residual soils are formed by weathering of rocks. So option is not there. So option D none of the above. Next question: water content of soil can. Option A never be greater than 100%. Take values only from 0 to 100%. Option C be less than 100%, 0%, and option D be greater than 100%. Here water content of soil can be greater than 100%. Option D is correct. Next question: which of the following types of soil is transported by gravitational forces? Here we have some varieties of soil. Here glacial soil is nothing but formed by transportation and deposition of glaciers, and of alluvial soils it is transported by running water and deposited along streams, and lacustrine soils which is formed by deposition in quiet lakes, under the lakes, and marine soils which is formed by deposition in sea or ocean. Next, aeolian soil, it is transported and deposited by the wind, and colluvial soils which are formed by movement of soil from its original place by gravity. So here option B is correct. The soil transported by gravitational force, it's also called as colluvial soil or terrace. Next question: a fully saturated soil is said to be. In a fully saturated soil there will be two phases. Here option C, two-phase system with soil and water, is the correct answer. Next question: valid range for the degree of saturation of soil in percentage is. The degree of saturation can be greater than 0 or less than 100. So option D is correct. Here option C and D are same. Next question: the submerged density of soil in terms of unit weight of water gamma W, specific gravity G, and void ratio E is given by the expression. Here we have four expressions. In this, option D is the correct answer. Gamma W into G minus 1 divided by 1 plus E. Next question: the soil has a bulk density of 22 kilonewton per meter cube and water content 10%. The dry density of soil is. Here we have four options. We have one formula to find dry density. Dry density gamma D equal to bulk density divided by 1 plus W. W is nothing but water content. So here bulk density is 22 kilonewton per meter cube and water content is 10%. So the answer is 20 kilonewton per meter cube. So option B is correct answer. Next question: if the voids of a soil mass are full of air only, the soil is termed as dry soil because it has only two-phase system, soil and air. Next question: valid range for N. N means porosity. The percentage void is. Here the value of porosity can be greater than 0 and less than 100. So option A is correct answer. Next question: select the correct statement. Here option A, unit weight of dry soil is greater than unit weight of wet soil. It is wrong because unit weight of dry soil is always less than unit weight of wet soil. Next option: for dry soils dry unit weight is less than total unit weight. That's also wrong. And option C, unit weight of soil increases due to submergence in water. That's also wrong because unit weight of soil decreases with submergence in water. Next option: unit weight of soil decreases due to submergence in water. Option D is the correct answer. Next question: void ratio of soil mass can. Here void ratio of a soil mass can be any value greater than 0. So option C is the correct answer. Here porosity should be between 0 and 100, but void ratio can be any value greater than 0. Next question: if the volume of voids is equal to the volume of solids in a soil mass, then the values porosity and void ratio respectively are. Here we have separate formula to find void ratio and porosity. Here void ratio equal to volume of voids divided by volume of solids. Here it is given that volume of void is equal to volume of solids. So void ratio will be 1. Next, porosity is nothing but N equal to 1 by 1 plus E. So we will get porosity as 0.5. So here answer is porosity equal to 0.5 and void ratio equal to 1. Here option C is correct. Porosity 0.5 and void ratio 1. Next question, when the degree of saturation is 0, soil mass under consideration presents. Option A, one phase diagram. Option B, two phase system with soil and air. Option C, two phase system with soil and water. And option D, three phase system. Here it is given that degree of saturation is 0, so the soil will be dry. So answer is two phase system with soil and air. Option B is correct. Next question, select the correct range of density index. Here we have one table for a density index. Density index can be 0 to 100. Here option C and D both are correct. Next question, if the degree of saturation of a partially saturated soil is 60%, then air content of the soil is. Here the summation of degree of saturation and air content will be 100%. So saturation is given 60%. So answer is 40%. Option A is correct. Next question, if the water content of a fully saturated soil mass is 100%, then the void ratio of the sample is. For this we have one relation, ESR equal to WG. Here W means water content, G is specific gravity and E is void ratio. Similarly SR is saturation. Here it is given that degree of saturation is 100%, that means 1, and water content also 1. Here 1 into G equal to E into 1. So specific gravity will be equal to void ratio. So option B is correct. Void ratio is equal to specific gravity of soil. Next question, the ratio of volume of voids to the total volume of soil mass is called. It is porosity. Option B is correct. Next question, relative density of a compacted dense sand is approximately equal to. Here we have one table for that. Here according to the relative density we have the type of soil. Here it is given that compacted dense sand, so we can take it as very dense, so it will be relative density will be 85 to 100. In option between 85 and 100 we have 0.95, so option C is the correct answer. Next question, if the sand is in its densest state, then the relative density of sand is. If the sand is in densest state means the relative density of sand will be 1. Option B is correct. Next question, which of the following method is most accurate for the determination of the water content of soil? Here option A is correct, oven drying method. Oven drying method is the accurate for determination of water content of soil. Next question, for proper field control, which of the following method is best suited for quick determination of water content of the soil mass? Here in option A oven drying method, option B sand bath method, option C alcohol method, and option D calcium carbide method. Here option D is correct, calcium carbide method. Here if they ask for accurate method, oven drying method is correct. If they ask for quick method, calcium carbide method is correct. Option D is the correct answer. Next question, a pycnometer is used to determine. Usually pycnometer is used to determine specific gravity and water content. So option C is the correct answer. Next question, Stokes law is valid only if the size of particle is. Here option C is correct, between 0.2 mm and 0.0002 mm. The maximum size of soil is 0.2 mm and minimum size is 0.0002 mm. So option C is correct. Next question. In hydrometer analysis for a soil mass, option A, both meniscus correction and dispersing agent correction are additive. Both meniscus correction and dispersing agent correction are subtractive. Option C, meniscus correction is additive and dispersing agent correction is subtractive. Here option C is correct. Meniscus correction is always additive and dispersing agent correction is always subtractive. Next question. The hydrometer method of sedimentation analysis differs from the pipette analysis method in option A, the principle of test, option B, the method of taking observation, option C, the method of preparation of soil suspension, option D, all of the above. Here pipette analysis is a method of measuring size of small particle. Similarly, the hydrometer method is grain size of fine-grained soil. Both are similar, but the method of taking observations are different. So option B is correct. Next question. Which of the following is a measure of particle size range? Here option B is correct. Uniformity coefficient is the measure of particle size range. Next question. Which of the following statement is correct? Uniformity coefficient represents the shape of the particle size distribution curve. For option B, for a well-graded soil, both uniformity coefficient and coefficient of curvature are nearly unity. And option C, a soil is said to be well-graded if it has most of the particle of about the same size. And option D, none of the above. Here all the options are wrong, so option D is correct, none of the above. Next question. Uniformity coefficient of a soil is option A, always less than 1, option B, always equal to 1, option C, equal to or less than 1, option D, equal to or greater than 1. Here option D is correct. Uniformity coefficient of a soil is equal to or greater than 1. Next question. According to Atterberg, the soils is said to be of medium plasticity if the plasticity index is. Here we have one table for that. For plasticity index, 0 means soil is sand and it is non-plastic. Plasticity index is less than 7 and greater than 0, that is silt and it is of low plastic. And plasticity index 7 to 17, it is silty clay and it is of medium plastic. And if the plasticity index is greater than 17, soil type will be clay and degree of plasticity will be high plastic. So here our question is 7 to 17, so it is medium plastic. So option B is correct. Next question. If the natural water content of soil mass lies between its liquid limit and plastic limit, the soil mass is said to be option A, liquid state, option B, plastic state, option C, semi-solid state, option D, solid state. By a graph we can analyze this. Here is the graph. It is between total volume of soil mass and water content. If the soil is in between liquid limit and plastic limit, it is called it is in liquid state, and if it is in between plastic limit and liquid limit, it is called plastic state. So here answer is plastic state. Option B is correct. Next question. The ratio liquid limit minus water content divided by plasticity index for a soil mass is called option A, liquidity index, option B, shrinkage ratio, option C, consistency index, and option D, toughness index. Here the ratio is nothing but consistency index. These are the different relations. Plasticity index is equal to liquid limit minus plastic limit. Consistency index is equal to liquid limit minus natural water content divided by plasticity index. Liquidity index is equal to natural water content minus plastic limit divided by plasticity index. Similarly, shrinkage ratio is nothing but unit weight of water divided by dry density. Here option C is correct. Next question. When the plastic limit of a soil is greater than the liquid limit, then the plasticity index is reported as. If the plastic limit is greater than liquid limit, the plasticity index will be 0. Next question. Toughness index is defined as the ratio of. Toughness index is the ratio between plasticity index and flow index. So these are the questions we discussed today in Geotech. I hope all are understood. So we'll see in next class. In next video.